Assalamualaikum to our lecturer for this subject, Machine Learning ISP560, Sir Muhammad Razif. We are from CS2424D. Will be present about the dataset Machine Learning. We have 4 members in group, which are me, Amira Nazira, Nurul Elijah Kila, Nurul Aiman, and Nurul Aisha. This present will start by me first, Amira Nazira. Okay, now I will present the introduction of the topic. There are many different types of animals that no one knows the exact number of animal types. Their classification accuracy on an independent test set and their complexity are used to evaluate the classification rules suggested by machine learning system. We will import data we import from the Kaggle website to Google Colab. And in Google Colab, few steps needs to be done for the Google Colabs recognize the data. Then, for each command state in Google Colab can be run and produce output based on the command given. Next, I will present the scope of this project. The zoo dataset was separated into 21 testing samples and 80 training samples to be used in analysis. The loading of the data is the first step in the process of generating the zoo dataset. This dataset involves 101 different kinds of animals that are wanting to be classified, and they have a total of 16 variables, which is 16 input layer that each define a different characteristic of the animal. The output count is set at 100 throughout the training process of the model, at which point it reaches an accuracy level that is efficient.
Now let me explain about problem. In this mini project, machine learning was used in classifying the types of animals that were being listed based on their characteristics, such as hair, feathers, eggs, milk, airborne, aquatic, predator, and the others. We used machine learning in our study as we wanted to solve the problems of arrangement error in handling many types of animal, especially when it is involved with large amount of data of animals and the mistaken introduction of animals by the zoo staff. Next, we will continue with the objectives of this mini project. The prime objective of this mini project is to be able to predict the classification of animals based upon the variables, which are the characteristics that I have stated before. This is the perfect database for those who are beginners in learning machine learning. Other than that, the technology of zoo also will be improved for the arrangement of many types of animals, especially with large amount of types of animals that were being located in the zoo.
Right. And now I'll be presenting about the demonstration, in which it contains of data type, system flow, and demonstration on predictions. We will proceed with the Python notebook. Our data type is classification. First of all, we have to import the modules, and the modules that we use are TensorFlow, NumPy, Matplotlib, PyPy, Pandas, Keras, StandScalar from sklearn preprocessing, TrainTenScalar from sklearn model selection, Render from Sequencer from sklearn assemble, Sequential from Keras.models, and Dense from Keras.layers. Our version of TensorFlow is 2.8.2. Next, we import the dataset before training and testing the model. The datasets consists of two files. The first one is zoo data that shows the input parameter of the datasets and numbers of animals that having the total of 101 rows and 18 columns. Then, the second file is class data that shows numbers of animals according to its class type. Then we split the data into X and Y. For X, we classify it as input parameter that we get from the zoo data. To normalize the data, we set the column name as standard scalar as SC. Then we use it to fit the transform of X and make the column name as X. For Y, we classify it as the class type from zoo data. For both X and Y having the type of integer 64. X having the shape of 101 and 16 while Y is 101. After we convert it into field of the data because the original data is whole number, so it is easier to run. For pre-processed data, we split the data into training and test set, in which the test size we set it into 0.2 and 45 for random state. We set up the model by using the random regressor for all the models that we're going to use to train, and we get the value of 0.991. To check the missing data of original data, we use the data.isna.sum, and it shows that our dataset does not have any missing values. From output 19 and 20, it shows that it is true that the original data having 101 classes. For output 21, 22, and 23, it shows that X-string having the length of the key, and to make sure if it is true, we run the length of X-string, and yes, it is having the same length of the key. Then we repeat the same process for Y-string and having the same length of the key. For the test data of X and Y, both showing the same values of 21 classes from our datasets. Next is to build the model. In this session, I will not explain it in details because we are going to explain it later on. But here, input areas and dance areas are used for the section. We create 4 models because we use different activations and optimizers to test the accuracy from each model. As for the first model, we use activation of value, and we compile the model by using Adam optimizer. The last function is TensorFlow that Keras analyzes the sparse categorical entropy and the matrix accuracy that used to monitor the training and testing steps. So this is the model summary. For the purpose of this project, we train the model to see the accuracy of different activation and optimizer that we used earlier. We set the epoch into 100, batch size is 8, verbals into 1, and the validation speed of 0.2. Then we evaluate the accuracy, and we can see the accuracy and loss of the model is we plot the accuracy and loss graph, and we can see from here the accuracy graph is keep increasing, which is good, and the loss graph keeps decreasing, which is good too. Then we make the prediction of the model. First, we need to know the probability of the model by using the function of TensorFlow that Keras exponential and TensorFlow that Keras that we use the softmax. Then we repeat the whole same process to build the next model. For model 2, we use the For model 2, we use the activation of sigmoid and optimizer of AdamX. And we train the model, and we can see from the plot of accuracy, it is increasing and the loss is decreasing, which is good for the model. And for the model 3, we use the activation of sigmoid and the optimizer of MS block, and we can see from the plot after we train it, the accuracy is increasing while the loss is decreasing, which is good too for this model. And then the last model, we use the activation of Relu and the optimizer SGD. After we train the model, we can see from the plot the accuracy is increasing while the loss is decreasing too. And overall, all models is good. For the last step is we execute all the results and predictions output in the form of CSV. So that's all for me. Thank you.
Next, I will be presenting the network architecture. We are using a fully connected neural network FCNN, or always known as a dense neural network DNN. Our fully connected neural network consists 3 parts, which is input layer, hidden layer, and output layer. For the first part, input layer, this pseudodata that we experiment on consists 16 inputs. Next, hidden layer. There are 20 hidden layers that link to the 16 inputs. Lastly, output layer. In this data, the output layer will be 8 output because there are only 8 classes of animal in this model. Next, this is a model summary that we obtained. If you can see, there are 2 layers in this model. The first layer, which is dense 22, always stated as input layer, have 20 hidden layers. And the number of coefficient is 340, weightage compute into the link bias. And another layer, which is dense 23 or output layers, has 8 output and the number of the coefficient is 168. Lastly, the conclusion. Our research has succeeded in developing a multiple feature on extraction method. If we see the previous slide, overall the accuracy of testing process for Adam optimizer and Relu activation was 95.23% and testing time was 0 seconds. That makes it the highest accuracy and better optimizer. This data also can give a big benefit for the user from the animal species classifier to make the people, especially a visitor zoo, familiar with the various type of animal and their class type. And that's all from us. Thank you and Assalamualaikum.